right. Before we move down to perfect squares, one of my student, rather one of my subscribers, was asking me that there is an expression that she was given. She was not able to factorize it either by grouping. So and such expression like this that has maybe 4 or 5 terms. What you do first of all with this kind of expression is this. You first of all identify the trinomial factors there and factorize it, or you find out the way you can, if it's a binomial or whatever. But if you have it like this what we have now, we can use this to illustrate this expression and find out the factors, right? Okay. All right. Now on this we say solution. First of all, we're going to find, like I said, we find the trinomial factors here and deal with it first. Okay. Now, me looking at this, we can go by. Remember, this is the one that has a raised to power 2. So you find those ones that are common to it. So we can say 2x raised to power 2 plus 4x plus 3 plus ax plus 3a. Something like this. Okay, now we have pushed those ones that has x apart from this. Now looking at this can go with the 3a. Okay, now with these are the trinomial factors here, the trinomial expression here. Now if you look at this, we can factorize this. Now remember what we did in factorization. We look at the multiplication, the product of this, and you find the words. Whatever you get, like that's 3a squared, or rather 3x squared. Okay, 3x squared. That's the product. Why the sum of the factors that you're going to get will give you plus 4x. Okay, please pay attention. Now, if you look at this, you can say okay, let's clean this. You can say x, okay, squared. Now, if you think of 3x squared and 4x, you may consider 3 and x, 3 and 3x and x. Okay, 3x and x, and remember this is positive, so we can say plus x squared. Okay, sorry, plus x plus 3x plus 3. Okay, okay, now look at this. If you multiply these two, you are going to get 3x squared. Okay, and if you add the 2, you're going to get 4x. Now we look for the common term here for these two here. Remember, this is we are coming for this. Okay, now this we say x in brackets x plus 1. Okay, plus 3 is common here, so we have x plus 1. Okay, plus ax plus 3a. Now we have x plus 3 and then x plus 1. Okay, now plus ax plus 3a. Okay, now looking at this, now we can decide, okay, to factorize this side. We can now have what's common here is a, so we have a into this ax, we have x left. A here is what? Plus 3. Okay. Now, if you look at this, you see that they are common. Okay. You write it out first. Remember, these are now separate entities entirely. Okay. With this. So you can decide to pick these two. X plus 3 in brackets. Now you represent this as well. This will now be x plus 1 plus a. Okay, so this is the final answer. So when you have something like this, attack it this way. You can have so many examples of this, but whenever you do it, please first of all identify the trinomial expressions there. You handle it alongside with the other binomial. All right, thank you very much. Okay, welcome back. Now, what we'll look at perfect square. What is perfect square? We can say that perfect squares are those algebraic or numerical expressions, that can be broken down into two perfect factors. Now, if you look at a number like 9, 9 has a perfect square what? 3. 9 is a perfect square that has 3 raised to power 2, that which is equal to 3 times 3. Okay, can talk about 16. 16 is 4, 4 times 4. Okay, and so on and so forth. 25. Okay, 5 times 5, and so on and so forth. Now you can equally look at maybe an expression that says you have a squared plus maybe plus 10a plus 25. Okay, now if you look at this, remember this is just like a kind of an expression, a quadratic expression. Okay, now if you look at this, you can say maybe if you are to factorize it now, you start looking for what? The factors by multiplying this, and you get the middle term that when you sum those factors, you get it. Okay, now you can equally have maybe something like a squared plus maybe 16a plus 64, and so on and so forth. Okay, so these are examples of perfect square. Now, if we are going to take some examples and give further explanation about perfect square, it's just a very simple and very tactical form of algebraic expression. Okay, now stay tuned while we bring you some examples to illustrate this. Okay. Let's use these examples to illustrate what we mean by perfect squares. Now, example say what must be added to these expressions to make it a perfect square. Now, these are the expressions. The first one is y raised to power 2 minus 16y. Okay, and the second one says 3x raised to power 2 plus 5x. All right. Number one. Now, this first one we can say let the value be. You can choose any letter. Maybe we'll say let's say t squared. Okay, because it's a perfect square. Whatever that is going to be here will make the expression to be a perfect square. So we say t squared. Okay, now let's go further. We can say y raised to power 2 minus y minus 16y. Okay, plus t squared. Now equal to. At this point now, for this side of the equation, we can say we can take these two things, okay, and equate it here. So this is what we mean. Okay. Now, at this point, we want to expand this. Expanding this, we have, remember this is raised to power 2. So we say y plus t, and again y plus t. Now, expanding this further, we have equal to, this times this is y squared, this times this is plus yt, this times this is plus yt, and this times this is plus t squared. Okay. Now, bringing this down, we have y raised to power 2 minus 16y plus t squared equal to, we bring down this, we have y squared, this plus this will give you plus 2yt plus t squared. Okay. Now, at this point, what we are going to do now, we are going to consider the we equate these two things, the middle term. Okay, we equate them. We have minus 16y equal to 2yt. Okay. Now, from this we can say divide both sides by 2y. When we divide both sides by 2y, now we have equal to, this will give us minus 16y over 2y equal to 2yt over 2y. Okay. Now, this we cancel this, then this we cancel here 8. So we have minus equal to minus 8 equal to, this 2y we cancel this 2y here, we have t left. So t is equal to minus 8. Now, remember what we are looking for, the value of what? T squared. Therefore, t squared is equal to what? Minus 8 raised to power 2. Okay, so equal to minus 8 raised to power 2 is just like saying minus 8 times minus 8, which is what? 64. Minus minus plus. Okay, so the answer is 64. Okay, so quickly we are going to take the second example. Okay, so stay tuned. Okay, all right, example 2. All right, just like we did in the first example, but looking at this one now, we have x squared to have a coefficient of 3. Okay, now in this we say 3. Okay, first of all, we want to find what we make it a perfect square. We say let the value be, let's still use t squared again, t squared. Okay, now we say 3x squared plus 5x plus t squared equal to, we are also going to take this and this outside the bracket again. We have plus the raised to power 2. Okay, so we expand this now. Expanding this, we have okay. Now this will be equal to, this times this is 9x squared. This times this is plus 3xt. This times this is plus 3xt, and this times this is t squared. Okay. Now So with this we have 3x squared plus 5x plus t squared equal to 9x squared plus this is 6xt plus t squared. Okay, now with this we say if we equate the two middle terms, we have 5x plus equal to 6xt. Okay, now with this we say further that okay, we divide both sides by what? We divide both sides by because we are trying to push this, eliminate this 6x, so we divide it with this 6x, divide both sides by 6x. So with this we have 5x over 6x equal to 6xt over 6x. So this we cancel this, while we have 5 over 6, while this cancels this. Now we are left with what? Equal to t equal to 5 over 6, y t squared now will be equal to this raised to power 2 is 25 over this raised to power 2 is 36. So this becomes the final answer. Okay, t squared is equal to 25 over 36. All right, thank you very much. That's the final answer.